Hello all, welcome to the next lecture video for lesson 7, and today we're going to go into strings and figuring out a little bit more about how to manipulate text. So we're going to be covering chapters 8.1 through 8.5 with C characters and strings. What we're going to do and how we're going to do this is we're going to introduce a few additional C standard libraries to help process those characters and strings. Right now, we've only used that stdio.h. We are going to look at that one, but we're going to add a few more to help that are very specific to characters and strings. We can use printf and scanf the way we've been using it, but we're going to expand it, because up until now we've only done numbers. We're going to expand it to include characters and strings. Now, some fundamentals about characters and strings. Every program is composed of characters, and when you put those characters together, it forms words, words form sentences, sentences form paragraphs. So a program can contain a character constant, and as far as the computer processor, the compiler are concerned, that character constant is going to be an int value represented by a single alphanumeric in single quotes. A character's constant value is that character's integer value in the character set. Now, basically, your machine, your compiler, it will assign integer values to things like A, B, C, even lowercase a, b, c versus uppercase A, B, C. A string is nothing more than a series of those characters that are treated as a single unit. So we can look at a word as individual letters or individual characters. When we speak of these strings, we can actually use other special characters as well. So we can use things like symbols, plus, minus, multiply, percent sign, ampersand, things like that. All of those are considered characters. String literals or string constants are going to be in double quotations. So if it's a single character, it's single quotes. If it is a constant string with multiple characters, you're going to use the one with the two or multiple quotation marks. All strings have a null terminator at the end, and it's going to be that /0. Without that, your computer won't know when your string is completed. So we're going to need to make sure that that is included at the end of every single string that we use. We can access our strings using a pointer to the first character. This is going to be very similar as to what we did with an array. We can think of a string as nothing more than an array of characters. So the string's value is the address of the very first character. This is exactly what we did with arrays. In C, it's appropriate to say that a string is a pointer to the string's first character, just like arrays, because again, it's just a simple array of characters. With a string, just like absolutely every other variable we've done, you do those first three things. We define, we initialize, we use it, right? So we can initialize a character array or a character array by using the asterisk with a string value. So here are two different ways to do it. The first way right here defines a character. We're calling it color. It's an array, and we're giving it the word blue. So it's in double quotes because there's more than one character, so we need more than one quote. We can also create it in this way. We can say character is a pointer to color pointer, and we give it in quotes the word blue. There is a difference between these two. This one has the word constant. The word constant makes it not modifiable. So I cannot change this value no matter what I do. If I do it the way that we've always done it, it is modifiable and it can be changed. We can also write this character array, and this is so much more like what we're used to seeing when we did the arrays in the last lecture. We can say character array, put the square brackets, we've got our curly brackets indicating it's an array, and we have all of our letters. don't forget that null terminator. We just talked about that. That has to be included at the end. It's automatically added here and here, but here we do have to specify it. When we look at a character array, it does have to be long enough to include every letter plus that null character. So this one is going to have 1, 2, 3, 4, actually 5 elements in it. The 4 letters plus the terminating character. You're allowed to store a string of any length using C, and just be mindful that if your string goes beyond what you have allocated, you may start overwriting memory that's being used for something else. So we just want to be very careful that our strings are within the bounds that we have set within the program. String literals should not be modified. Okay, so we don't want to modify a string, especially when we use that const in front of it. When we read a string with scanf, this is what we've done before, except we've used with numbers, right? We've used %d, we've used %f. Now we can use %s for a string. The other thing to notice is that if we're doing a string, we do not need the ampersand because it treats the variables of a string as if that ampersand is already there. The number 19 here is going to read a maximum of 19 characters. So we want to make sure that whatever the user is inputting, it is at maximum 19 characters. Always use a field width when reading strings with a scanf. This is going to eliminate the possibility of a user just putting in an infinite amount of data. Character handling library, our new standard library. We've got a new one here called ctype-h, ctype.h. And this is a character handling library. So all the functions that test and manipulate character data, you're going to find in this ctype-h. Each function is going to receive a character. Remember, those characters are represented as integers, or an end of file, EOF, or a null terminating character. Characters are often manipulated as integers because a character in C is a 1-byte integer. So we were able to put all of the numerics and the letters and the symbols all within the 1-byte integer. And typically your EOF is a negative number, a -1, because remember, we are representing the unsigned. So let's look at a few of the character handling functions that are available in that library. So here we've got isBlank. Now remember, these are on characters, not strings. I can determine if a character is blank. I can determine whether it's a digit, an alpha, is an alphanumeric. Alphanumeric is a digit or letter. All of these so far are going to return true and false. Is X digit, which is a hexadecimal digit, is a lowercase digit, is an uppercase digit. You can even force a character to be an uppercase or a lowercase. This too lower or too upper is used a lot when we're dealing with passwords that are not case sensitive. Nowadays, most things are case sensitive, but if you don't want it to be case sensitive, the first thing you're going to do with the input is do an all too lower or too upper for all of the characters in the word. Here's my too upper. We can also determine if it's a space. We can determine if it's a control character. Those control characters from, I think, day 1 were a lot of those that had the slash in front of them. Okay, so we've got a tab, a form feed, an alert, a backspace, carriage return, new line, things like that. Now, one thing to note is that your is space is considered if it's a white space character, not necessarily just a space. Is punctuation returns if it is a value of basically any symbol. Is print determines if it is a printable character, so something that is visible on your screen. Now this does include your space. It would be false for something like an alert or a beep. Is graph returns a true value if it is a printing character other than a space. And again, most of these return trues and falses. The two upper and the two lower do actually manipulate the character itself. Let's take a look at some code using some of this character manipulation. We're going to look at is digit, is alphanumeric, and is X digit. So here, there's a few things to note. The first thing I want to point out is on line 7, this is a different way of doing an if statement. Okay, so is digit returns are true or false. So you can put an expression here, and you could put a question mark, which basically says, is it true? If it is true, do the first one. Otherwise, do the second. So basically we're saying if the first statement, do this, else do that. It's just another way that we can do an if else. Saves a little space, saves a little time. That's not what's really important here, but let's take a look. So first we've got is digit. Okay. It looks and compares, is 8 a digit? And it is. So it says 8 is a digit, and a hashtag is not a digit. Here we've got is alpha. So A is a letter, B is a letter, an ampersand is not, and neither is the number 4. Here we've got is an alphanumeric. Now alphanumeric, remember, is a letter or a number, both upper and lowercase. So A is a digit or a number, 8 is a digit or a number, but a hashtag is not. Down here we've got X digit. Now remember, that's a hexadecimal digit. Hexadecimal digits go from 0 to 9 and then A to F. And we do include capital A to F and lowercase a to F. So first of all, capital F is, capital J is not. 7 is because it's a number, a $sign is not, but a lowercase f is as well because we take upper and lowercase. Here we're going to look at a few more functions. Now these are going to be is lower, is upper, and then the two lower and two upper. Now remember, is lower, is upper is going to give a true or false, and then the two lower, two upper is actually going to do the conversion. If we take a look at this code, my is lower here, I send it a lowercase p, a capital P, a 5, and an exclamation point. Now my lowercase p stays the same, my uppercase is not a lowercase, my 5 is not lower, and my exclamation point is not lower. So if it is a symbol or a numeric, it comes back as false. Is upper is basically the opposite. D is an uppercase, lower is not. Those are obvious. But again, your numerics and your symbol are going to come back as not. So your numerics and your symbols are neither upper nor lowercase. Here at the bottom, we've got a few two uppers and two lowers. So if I convert a lowercase u, I get a capital U. Now, if I do try to convert a number or a symbol, it just keeps them the same. Does not error, it just keeps them the same. Even though we have determined that it's neither upper nor lowercase, the functions are smart enough to know that, and it just returns what was sent. Now, on the other hand, if I send it a capital L converted to a lowercase l, gives me the lowercase l. Again, we've got a handful more. So is space, is a control, is punctuation, is printable, and is graph. So for my first one up here, I am looking to see if it is considered a space. So according to is a space, the first one I send it is a /n, and it is a white space character. I send it a /t, and it said it is a white space character. But then down here I send it a %, and that is not. For control characters, new line is a control character. You are controlling where you are. Except a $, that's not. Is punctuation. So my semicolon is, my Y is not, because it is a letter, so it's not punctuation, but my hashtag is considered punctuation. So remember, most punctuation are all the symbols. So it may not be, you may not think of a hashtag as punctuation, but for our case, we do consider it punctuation. Is printable. These are always fun. So a $sign is something you can print. Here I've got an alert character, which is a /A, which usually gives you a beep, and that is not. According to isgraph down here at the very end, Q is a printing character other than a space. And here I sent it just a single quote space, single quote. That is not a printing character other than a space. Now that we've looked at characters, let's expand that and include strings. In order to use strings, we have another library that we can add called the General Utilities Library. And it's just an STD for standard and LIB for library. So standard library.h. In this, it's going to have a lot of functions usable for strings or things in those double quotes. It's going to convert the string into some kind of numeric that your computer can understand, because remember, our computers only work in binary, so it has to convert those alphanumerics into something that is numeric. Let's look at the next table that has a bunch of different functions that we can use. So here we've got something that is a string to a double, strTOD. So it converts the string end pointer to a double. So end pointer here is going to be what is sent, and it converts that string to a double. Here, string to L, string to a long, does the same thing as what the double, but the long integer. And here we've got string to unsigned long, UL. So it is going to convert whatever that string is to an unsigned long. We can do this if we ask for a number. We can read it in as a string, and then we can actually convert it to a number to use with arithmetic. Let's take a look at this string to double, str2d. And what it's going to do, it's going to convert a sequence of characters representing a floating point to a double. It's going to return 0 if it's unable to convert part of the argument to the double. So if there's something in there that says, hey, I'm not a double, I can't be a double, it is going to return 0. It's going to receive 2 arguments, a string and then a pointer to a string. So we've got a pointer to a string, right? So that's why there's 2 asterisks there. The string argument contains the character sequence to convert. White space characters at the beginning are ignored. So you can have space, 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 and then your number starts, and it won't give you the 0, it will just ignore it. Let's just go ahead and take a look at the code. So here I've got my code. I've got my constant character, which means I cannot change the value in here. What I have set it equal to is in double quotes here, and it says 51.2% space R space admitted. Here I've just created a string pointer. I've set it to null. Here, double D, string to double, I'm sending it the string and I'm sending it the pointer. We're going to do a little crisscross. So string to double is going to march down that string and pick out the double. So it's going to pick out 51.2. So the string, here's my %s, and I sent it string. Okay, so this right here is going to be the whole thing. The string 51.2 are admitted. That's the original. Double value of, here we're giving it a float, and the string %s. So f float 0.2, 2 decimal places. I'm sending it D. D is what was sent or returned from my string to double. what I get there is the 51.20, and notice I used a float here, so it is actually a number at that point. Here, the rest of the string is in the string pointer. So the second part of it is what is remaining in the string once the double is removed. So then I've got leftover, % are admitted. Let's take a look at string to long. Again, it's very, very similar to what we just did in double. So let's go ahead and get into the code. Here I've got my constant character. I cannot change it. It will not change. I've got negative 1, 2, 3, 4, 5, 6 ABC. Here I've created my pointer, which is going to be the characters at the end that have nothing to do with the number. So here I've got the original string is string that prints the original. The converted value. So X is going to be what we get back from string to long. And it's going to be the numeric part of the original. So it's going to be negative 1, 2, 3, 4, 5, 6, 7. The remainder of the original goes into the rest of the pointer, and that's going to be the ABC. And then I can add, just like I can do with any other numeric, to that X, because at that point it is a number. Last but not least, we've got string to unsigned long UL, and it works identically to what we've done before. So here I've got my constant character, cannot be changed, 1, 2, 3, 4, 5, 6, 7, A, B, C. I've got my pointer pointing to null. Here I am executing my string to unsigned long. I'm sending it the original string and the new pointer, and I'm sending it the 0. Here, line 10 assigns X the unsigned long int value converted from a string and aims the remainder pointer at the A in the string. Now that third argument 0 is going to indicate that the value to convert can be in octal, decimal, or hexadecimal format. I don't care. I can indicate which one I want, but for this, I'm not really minding. So my original string is going to be that 1, 2, 3, 4, 5, 6, 7, A, B, C. The converted value is just the numeric. What's left over is the ABC. I can then subtract a number from it just like I would any other numeric. So we're going to take a quick dip back into my stdio, which is what you guys have been using all along. Okay, and we're going to take a look into some of the character and string manipulation functions. What we have here is we have a few different ways to work with strings and characters. So we have a getChar, and that is going to return a character from the standard input. Okay, standard input for what we've been doing so far is the keyboard input from a user. We can use a function called getS. We can also use putChar. So putChar prints getS, reads characters from the stream into an array until a new line or end of file is encountered. Okay, so this will read in characters into an array until the enter is pressed. Or if you're reading from a file, end of file. Here we've got putS, which prints a string. We've got sprintf, which is going to be the same as our printf that we've done, but the output is stored in an array S instead of being printed on the screen. And then scanf is going to read the input from an array S rather than getting it from the keyboard like we have with scanf. Let's take a look at a few of these functions that are, remember, these are in the stdio that we've used up until now. So let's look at the getChar. Remember, getChar is going to read a single character in from the keyboard at a time. So here I've got a character array sentence. I've also done two integers, I and C. So C is going to be the variable to hold the character that the user input, because remember, it's going to read it as a integer. Put S, enter a line of text. It is going to just go ahead and put that on the screen. Now, put S only works with strings. It does the same thing as printf. So those two are interchangeable as long as you're working with just plain text. Next, we're going to create a while loop from 12 to 14 here. And what that's going to do is read each individual character that the user is pressing on the keyboard and being entered in, and it's going to put that into the character array sentence. So, while I is less than the size, and here my array is of size, we're going to go ahead and use that constant to make it easily changeable. So while I is less than size minus 1, because remember we always start at 0, so you have to shift it down. That's the logical and. C equals get character. That is going to get the character read in off of the keyboard. So while I'm within size and whatever I get is not a new line, I'm going to add that character to the array. So I type in the letter capital H, it puts it in the array. I do capital E, it puts it into the array. It does all of those into the array. When it gets to the end here, the user presses the return or enter key, and it's going to, this right here is going to be true, and it's going to kick out of that loop and come down to 16. Then we have to add that terminating character onto my string. It's not automatically put, we have to put it there intentionally. After that, I do a put S to display the words the line entered was, and a put S. One thing we need to notice, it does add a carriage return at the end. You do not need the /n with put S as you do with printf. But then what we can do here is put S and just sentence, and we can just send it the variable of the sentence array. And what that's going to do is it's going to display whatever was typed in. sprintf. This works very similar to printf, has the same conversion specifications as printf, and then remember, those conversion specifications are the percent signs. But it's going to print the formatted data into a character array. So this is a way that you can store a string by including variables and things like that so that you can actually use your put S. So here I've got my put S, enter an integer and a double. It's just a print. Here I'm going to do a scanf. This is the same scanf that we have done before. But one thing to notice, here we're looking for two different values. We're going to store it in two different variables, and all I have to do is put a space in there for the input to notice that there are two separate inputs. Once I hit that return, int number is now going to have 298 and double number is going to have 87.375. Here I'm creating my character array using my constant of 80. And here's my new line, sprintf. So I'm formatting a string, and it's going to save it into that new character array I created, S. And what I want it to say is integer. Here's my conversion spec with a new line, my double, my conversion spec. I want to put this one into the first conversion spec. I want to put that variable into the second conversion spec. All of that is going to be saved in S. So line 13 doesn't actually print anything to the screen. What prints to the screen is here on line 15. I use my regular printf. The formatted output stored in the array S is, and I put a new line. So that gives me this line right here. And then I send it S by using the conversion spec %S. Well, what is an S are these two lines here, which was created on 13. So you can see how we can use that sprintf to create strings as we go, and then our printf isn't going to be as muddy looking and as difficult looking. Again, same thing with the scanf. Here I can say scanf S. I've got my two values here. I put them in X and Y. Put S, the value stored in the character array R. Now, big thing here is that it's putting it into S. It's getting from S. So it's not getting it from the user. It's getting it from a string that was already indicated before. And it is putting it into, breaking it up and putting it into X and Y. That's why you don't see any kind of prompt up here for the user to enter anything. These values are coming directly from the definition and initialization done on 5. 10 is just a put S, and 11 is just going to be a print F, pretty much the same as the sprintf from the previous example, but is going to go ahead and put the integer on one line and the double on the other. Hopefully this has helped assist you in looking through some characters and strings. They're a little bit more difficult than working with the numbers, but we're going to be adding to this toolbox and we'll get it expanded. So right now we've got 2 homeworks, 6 on pointers, 7 on strings, and 2 labs, 8 on debugging, 9 working with pointers. So the debugging does not have pointers or strings, and our lab work is not going to have any string input this week. Next week, we're going to look more at strings by using formatting, input and output, and we're going to look at some bit manipulation, structures, and unions. Please don't forget to fill out the homework assignment that is for your final project. And if you've not watched that video, go ahead and watch that now to get a little bit more information on that.